problem. You got this right here. This is what it says. How do you compute this? What are you going to do? Factor and cancel, right? You're going to make sure the bottom is heading towards 0. You're going to check the top. If it's heading towards 0, you're going to try to factor and cancel. If it's heading towards non-zero, your problem's over. It's D and E, right? If the bottom is not heading towards 0, probably just plug the number.
Let's say if you have an x plus 1, then the bottom you have an x minus 1.
Just have an x plus 1 on the bottom?
Yeah, where you use the difference of 2 squared, just use x plus 1. X squared plus 1, then the bottom you have x minus 1. Limit.
Oh, if at the top is x squared plus 1?
Plus 1, yeah.
That doesn't factor.
Where you use the difference of 2 squared, just tell us.
Where you do not
use the difference of 2 squared, where you expand the x squared minus 1.
Hold on 1 second, sir. Let me make sure I understand what you're saying.
Yeah.
If we had
x squared plus 1
over x minus?
Correct. Minus 1.
Yeah. Limit as what? X goes towards what?
X was 1.
Goes towards 1?
Yeah.
Okay, good question. Yep.
Yeah.
You had a question prior?
Yeah. For the polynomial, the only reason this is a polynomial is because of the whole, right?
This problem is not a polynomial.
I mean, the
What?
setup for the whole makes it. The whole reason we factor is because of the whole, right? You have to account.
That's correct. That's right. It turns out this thing is a polynomial except for the whole, right? So once we remove the whole issue, meaning HOLE, the whole issue, you're left with the polynomial, and now you are allowed to just plug a number in.
Okay.
Okay? It's when you reach a polynomial state inside the limit that you can just plug the number in. Okay? So fundamental rule for limits. You can plug in numbers into polynomials. Or 1 second, let's get back to your question here real quick. In this case, let's look at this. What is happening to the bottom? As x goes towards 1, what is the bottom heading towards?
0.
Scary. All right, so now, what's the top heading towards?
1 or 2.
Infinity.
It's heading towards 2. The top itself is heading towards 2. And 2 is non-zero. So therefore, what's the answer to this problem? D and E. D and E. You should not answer infinities in these cases. You don't know if it's heading towards positive infinity, negative infinity, maybe one side's one, one side's the other. You probably don't know offhand. I wouldn't answer infinities. I would say D and E. Right? Yeah.
How do you determine the way the top and the bottom are heading towards 0?
Yeah, that's good.
In this case, you're just looking, like in a sense, what would happen if you plugged the number in?
And that's what I want to.
What would happen if you plugged it in?
And
Okay.
so-
This would become 0 if you plugged it in. Yeah.
And so in this case, because I sort of just took a guess actually.
Yeah.
So when we so to get the 2, is that pretty much plugging in the 1
Yes,
from
you
the
were
x
thinking
going
about
to?
it as if you plugged it in. That's right.
Okay.
Now, granted, that's not the answer to the limit, right?
Mhm.
But that is a guide as to what the thing is heading towards in this case.
Okay.
Yeah.
So it means it's coming from negative to 1. Is that what you mean? From 1, 0, negative 1, negative 2, negative 1, 5. What I'm saying that.
Yeah, but from both sides. That's correct.
But the last limit is 1, right? It's coming from 1, 0, minus 1, minus 2, minus 3, etc. to infinity. What I mean,
Hold on a
like the
second.
numbers
Here?
that we plug.
This one?
Yes, if it's 1.
Then it's like
All the
this.
other rest of the numbers should be 0, minus 1, minus
It's
2.
like you're going from 0.9 to 0.99 to 0.999. Right, you're getting closer and closer. 0.9999.
Gotcha.
Getting closer and closer and closer to 1. Right?
Yeah, but what I'm saying, like, yeah, let's say x is 1.
X is 1.
Well, I mean, the limit is 1. You have all the other fact that, like 0, 0, minus 1, minus 2.
No, you don't have to come
Well,
from
you
that.
shouldn't exceed 1. Is that what you mean? You should
In a
go
sense,
to
but the way you think about limits is being very close.
I don't even want to hear
You're very
it.
close to 1 is what you think about.
Gotcha.
You don't want, when you're approaching 1, you don't want to think, I'm heading from negative 10,000, negative 9,999, negative 9,998, and then eventually I'll get to 1.
Gotcha.
Right? You want to think I'm extremely subtly close to the number 1. Right? That's how you want to think about it. Any other questions so far?
So in this case, you just plug in the 1, right?
Yes,
Maybe
you're thinking
two.
about it as if you plugged in number 1. That's correct. If you plugged in 1 right now, this would be 0. So it's heading to this one, it's heading, the bottom's heading towards 0, the top's heading towards 2. Since this is heading towards 0, this is heading towards non-zero, it's heading towards some sort of infinity, which is a D in this case. So this one does not even factor, right? X squared plus 1 is non-factorable, right? You're going to see both of these cases quite often. This is a difference of squares. I want you to forget these things. It's difference sequence of squares. This one is a sum of squares, which is why I'm glad Sumura mentioned it. Sum of squares. Sum of squares is not factorable over the reals. So with real numbers, you cannot factor this thing. Okay? But the other one you can. What's the matter? We get meaning.
Sorry. I had a question about the limit of P of X equals P of A.
All we're saying is plug it in. Plug it in. When it's polynomial, you can just plug it in and that's the answer.
Oh, I thought it was like X approaches A.
It is. X approaching A.
Oh, so
As X approaches A, P of X approaches its function value. A stuck in there. All that means is, if you have the most standard functions on the face of the planet, which you know is polynomials have no breaks, no asymptotes, no holes, no funny business. So no matter what you should select here, let's say you want to approach that value right here, we'll call it 4. As X approaches 4, right, and this is P of X, as X approaches 4, what is P of X approaching? Its own function value, right? Everywhere, always, very polynomial. You're always approaching the function value itself. Because there's no funny business with polynomials, right? There are no holes like this in a polynomial. You guys know what I'm saying? As you approach 4, what's the function approaching? Whatever the height is at 4, right? P of 4. That's all it is. That is okay? That's the word of polynomial. So that was one standard example from the textbook. Let's see what else. You guys getting scared?
Yep.
Out of math or the rain?
Both.
I hear.
Both.
Oh,
Oh my god, look, that's number 39. I'm so good. That's number 39, Cornejo. Told you.
39 for what?
What's that?
39 for what?
Section 2.3 is number 39. Has this exact same expression. I'm telling you.
Oh.
These things are predictable. 41. Number 41. It's very similar. I'm leaving out the limit laws for one moment just to give you an idea of how to approach this. You don't have to think about the limit laws so much, and you won't after section 2.3. You're not going to be constantly worried about them. So I'm avoiding them for the moment. You don't know what I'm talking about, don't worry about it. 41. Section 2.3. It's so similar, maybe you can just eyeball it. What? What's that?
0 over 0.
How do you know there's a hole?
Because it approaches 4 and it's 4 minus 6.
It's 0 over 0.
It's a 0 with 0 case, right? So first look at the bottom. What's the bottom heading towards?
0.
0. So then next thing look at the top. What's the top heading towards?
0.
All right. So it is a 0 with 0. We'll call it a 0 with 0 case. Okay? It'll be called this for real later on when we talk about the Hobbitals. We'll go over those two